Can we create or destroy matter? What do you think? Alright, you have all seen the growing of a tree. A small seed changes into a big tree with the branches, the leaves. Do you think if you keep that seed in your room, leave it for say 1 year, 2 years, do you think a tree will grow in your room? You know it won't. Now take the same seed, take it to your garden, plant it in the soil. Do not water it and again leave it for 1 year, 2 years and so on. Do you think a tree will grow then? You know it won't, because you need to constantly water the seed. This is what happens. When a seed becomes a tree, it needs a lot of things. It needs sunlight, it needs soil, the manure, the nutrients from the soil, it needs water. So all these external matter, these factors, the soil, water, sunlight, chlorophyll, this is changing into the tissues and cells inside the tree. This is how the cells are dividing inside the tree and the tree grows. So one form of matter, that is the soil, the nutrients, the water, is changing into another form of matter. What happens during Diwali? You bring a rocket, you light it, and you see that the rocket goes in the sky and it vanishes. Well, have you destroyed your rocket? That means, have you destroyed matter? Okay. So when you light the rocket, you see sparks, you see pollution, you hear a sound. So you have not destroyed the rocket. Instead, you have converted it into different forms. The forms of pollution, sound, sparks, and so on. So we do not create or destroy matter. Matter can never be created or destroyed. It can only change its form. And this is known as the law of conservation of matter. That is, matter can never be created. It's neither created nor destroyed. It only changes its form. The concept of law of conservation of matter was taken as a specific case of law of conservation of mass by a scientist named Antoine Lavoisier. He said that in any chemical reaction, so this is a chemical reaction, so you take a substance KCl and this is a solution AgNO3, that is silver nitrate solution. It initially weighs 300 gram. Now, you pour the KCl in this AgNO3 solution, a chemical reaction takes place, it forms a compound, this precipitate silver chloride, and it forms a solution KNO3. You'll notice that it again weighs 300 grams. So in any chemical reaction, mass is always conserved. It is neither created nor destroyed in a chemical reaction. This is true for all chemical reactions. So if you have calcium carbonate, it weighs 100 grams. So experiments show that the amount of calcium oxide which is formed is 56 grams and the amount of carbon dioxide which is released is 44 grams. So in any chemical reaction, the mass, so you get 56 plus 44, which is 100. So the mass in any chemical reaction is always conserved. So let's take a question. We have 15.9 grams of copper sulfate and 10.6 gram of sodium carbonate. They react to form 14.2 grams of sodium sulfate and 12.3 grams of copper carbonate. So are the results in agreement with the law of conservation of mass? Let's just take the reactants and the products one by one. So we have 15.9 grams of copper sulfate and 10.6 grams of sodium carbonate. Let's add them. So we get 26.5 grams of the reactants. Now let's take the products. So we have 14.2 grams of sodium sulfate that is formed and 12.3 grams of copper carbonate that is formed. Let's add this. So we get 26.5 grams of the products. So 26.5 grams of the reactants, they form 26.5 grams of the products. So yes, the results are in agreement with the law of conservation of mass. So yes, they follow the law of conservation of mass. The ancient Greek philosophy says that nothing comes from nothing. That is, nothing new is created, nothing is destroyed. Everything just changes its form. So this is the law of conservation of matter.